Hello students, today we will discuss about laws of chemical combinations. In previous lecture we have discussed about the matter, its classifications in detail. So what are laws of chemical combination? From where these laws arise? Actually these laws obtain due to quantitative study of chemical changes. After a series of experiments under quantitative study of chemical changes, some laws appears that are called laws of chemical combinations. So first among laws of chemical combination is law of conservation of mass. Conservation of mass. It's clear from name that in overall chemical change, the mass will be conserved. There will be no any change in the mass, neither it will increase nor decrease in a chemical change from reactant to product. It was proposed by A. Lavoisier. A. Lavoisier proposed this law of conservation of mass. Let's consider one hypothetical equation A converts into product B. Here A is reactant while B is a product. When a chemical change is carried out in which A converts into B, then overall mass before the reaction will be equal to the mass of the product after completion of the reaction. Means in overall chemical change, the mass of the matter was conserved, was not changed. Overall mass of reactants was exactly equal to the mass of product. This is called law of conservation of mass. Taking one real example like NaOH, a base reacts with HCl, acid. Sodium hydroxide is a base, reacts with HCl and formation of a salt NaCl with H2. This is a chemical change in which sodium hydroxide reacts with hydrochloric acid, NaCl is formed with water as a byproduct. So before a chemical change, since we know atomic mass of sodium is 23, oxygen is 16, hydrogen is 1. So putting the value 23 plus 16 plus 1. 1 plus and chlorine is 35.5. 35.5. Now it's 23 plus 35.5, 2 hydrogen plus 1 oxygen. Before a chemical change, it will become 40 plus 36.5. It will be 0.5, 58.5 plus 18. Now complete addition 0.5, 6, 76.5. Now here 0.5, 16 carry 1, 5, 1, 6, 1, 7, 76.5. Since in a chemical change, total mass of the reactant is exactly equal to the mass of product formed, that's why this states and represents clearly about the laws of conservation of mass. There is no any change in the mass of the matter in the form of reactant and in the form of product. On the both sides of the chemical change, overall mass is same. Here NaOH is a base, HCl is an acid. So this reaction, here salt is formed. So this reaction is a category of neutralization reaction. Neutralization reaction. Now next, if silver nitrate AgNO3 reacts with potassium chloride KCl. Now, since we know silver has atomic mass 108, nitrogen has atomic mass 14, oxygen is 16, potassium is 39, and chlorine is 35.5, putting the value. Now here first product, silver and chlorine AgCl is formed with KNO3 potassium nitrate. This silver nitrate precipitate is formed is of white color, white PPT is formed. Since precipitate appears, that's why it's a type of precipitation reaction. It's a type of precipitation reaction and exchange of ions takes place. That's why it's a category of double decomposition. You have studied in class 10th, double decomposition reaction. Putting the value here 108 plus nitrogen 14 plus 3 oxygen 3 into 16. Now here 39 plus 35.5. Here 108 plus 35.5. And next 39 plus 14 plus 3 into 16. You will get overall value obtained in the case of reactants and in the products will be same. The value obtained will be same. You may put the value after addition of these masses, atomic masses in the reactant side and in the product size. Both the values will you obtain will be same. That's why this also explains about the law of conservation of mass. So I repeat the law. In a chemical change, when a reactant converts into product, always the mass will be conserved. There will be neither increase nor decrease in the mass when it converts from reactants into product, whether it's a chemical change or a physical change. It's a chemical change where a new product is formed from reactants. If we take a physical change like water heated strongly in presence, it exists in liquid phase. Now after heating, water vapors are formed in gaseous phase. In both the cases, the total mass will be same. Total mass will be same in reactant and product. So it also explains about law of conservation of mass. When a matter goes under a physical or a chemical change, the total mass will be conserved. There will be neither increase nor decrease in the mass. The overall or total mass of the reactants will be exactly equal to the mass of products. Now some limitations regarding law of conservation of mass. It's not applicable in the case of nuclear reaction. For competitive aspirants, note this point here that as well as the matter concerned to the nuclear reactions, this law is not completely applicable because in simply chemical change, in a simple chemical changes, whether it is endothermic or exothermic, whether a reaction carried out under absorption of the heat or elimination of the heat, in both the conditions we have studied in class 10th, In a chemical change, whether it is carried out under endothermic or exothermic changes, in normal reaction other than the nuclear reactions, the change in the energy is so little amount of energy is changed that the change in the mass will be negligible. In normal chemical reactions, the change in the energy is so little that change in the mass is negligible as per E equal to mc square. Due to very high value of C, the change in the mass is negligible due to change in the energy. When a chemical change is carried out in the reactions other than the nuclear reactions. But when the matter is concerned to the nuclear reactions, the change in energy is very high. Very high change in energy is carried out. So change in the mass cannot be ignored. Cannot be ignored. So, law of conservation of mass is not completely applicable in the case of nuclear reaction since the energy released is very high. That's why the change in the mass cannot be ignored, and this law is not applicable for the nuclear reactions. It is only applicable in the case of simple chemical changes, whether these are endothermic or exothermic by nature. So, this is all about the law of conservation of mass. It was proposed by Lavoisier, and in the next lecture, we will discuss about the law of definite proportion. Thank you.